All right. Focus of this question is formal charge. Kind of a unique way of asking it. It's asking a question about this central atom, but essentially we still have to know the equation for formal charge. And formal charge is really a check for us to see if the Lewis structure is viable or not, or if another type of structure is likely. So even though we may have the right amount of valence electrons used, is there another way that might be better? Which structure is the best? Formal charge can help us. And so the formula for that for formal charge is for each atom is valence electrons that the atom brings, and you subtract the number of unshared electrons, and then you subtract the number of bonds. So in this case, it's asking which element is possible to have a formal charge of 0. So we're working backwards. So what we need to do is find what this is in order to equal 0. And so what we see is we have number of unshared electrons. We have 2. And then we have 1, 2, 3, 4 bonds. So what number minus 2 minus 4 equals 0? And so we get a 6. So it has to be something in that 6A or 16 column in our periodic table that brought 6 valence electrons. So if we look at our periodic table real quick, we see that we're looking at this column. Now it's shared, so that lowers it to here, S or Se or oxygen. But another thing we learned is that you can't exceed that 8 octet for the central atom unless you're in period 3 or below. So that would be just sulfur and Se. Oxygen cannot do it. These have access to those 3D, 4D orbitals, and so they can exceed that octet, whereas oxygen cannot. It does not have access to the d orbitals. So we are left with just sulfur and selenium. So if we jump back, we see this response here. Now you might have thought this one, right? But that oxygen is not available to exceed the octet, right? Because we have 2, 4, 6, 8, 10. So kind of a two-part question: formal charge and exceeding the octet, which leads us just to B. There we go.